Okay, so if you just take down that pattern there, 1, 5, 11, 19. So can anyone tell me what is the differences here between these numbers? Four, 6, and 8. Very good. Yep. So we have our first difference is 4. Our second one here, sorry, or between 11 and 5 is 6. And between 11 and 19 is 8. Can anyone tell me what the next two terms of the sequence is? Thank you, Shemek. Can anyone tell me what the next two terms of that sequence might be? 29 and 41. Yeah, very good. So 29 because you add 10, and 41 because you add 12. Anyone not sure about that? Everyone seems to be okay with that? Okay, so can anyone tell me anything about the differences? Not of 4. It increases by 2 every time. Very good. So we have 2, 2, 2, and 2. Okay, so a quadratic pattern, and I'm going to write this out. A quadratic pattern, you can take this down, is one that, quadratic pattern is one that has a second difference, which is constant. So it has a second difference which is constant. So when we look here, just to show you, this is what we're talking about. These ones here are what we call my first difference. And if they were constant, we would know that they are linear. And then these ones here are my second difference. And when they are constant, we know that that's a quadratic. Okay, any questions on those? Type it into chat if you're not sure. So most of you were able to see how we figure out that how we got these two. That you are just adding 2 onto the first difference each time. Okay, on that, the 2 questions that we had a second ago, so I'm just going to make this a little bit smaller. Zoom out a little bit. Our last, in the recap there, or the little revision exercise we did, we have these 2 quadratic equations. And we can see that these 2 quadratic equations, 2 to 3, 1, 3 to 4, 1, 4 to 5, 1. So that's definitely quadratic. Second difference is equal to 1. Okay? Would there ever be a third difference which is constant? No, I've not come across third differences which are constant. We'll look at exponential later on, and exponential, you'll see a pattern in the third difference, but you won't exactly see a constant third difference. Okay? So second difference is equal to 1 in the first one. If we look at the second one, so we have -2 to -4 is -2 of a difference. So can you just check these on the calculator? If you struggle with integers, or you struggled last year understanding integers, check them on the calculator. Minus 4 to minus 6, minus 2, and minus 6 to minus 8, minus 2. So my second difference, because we know it's quadratic, is equal to minus 2. Okay, so that's what quadratic patterns look like. That's how we figure out quadratic patterns. Okay. So, I'll just remember from this. So, a quadratic equation always has a squared term, a squared variable or term. Okay, otherwise it's not a quadratic equation. So that's really, really important. In this case here, if a was equal to 0, then 0 multiplied by n squared would equal 0, and it would not be quadratic. Okay, that's kind of really important to say that. That's why we say a has to be greater than 0. Okay, it can be 0.5, it can be 0.1, but it cannot be 0. It can be negative, it can be so it can be less than 0, so it can be minus 1, minus 2, minus 3, but it cannot be 0. And then finally, B and C are elements of the real number system. They just have to be numbers. They have to exist. They can be 0. B can be 0, or C can be 0, because it will still remain a quadratic equation as long as we have an n squared. Okay? We're just going to look at, first of all, and I don't want you to take down all this writing. Let's work with the steps. So take down step 1 for the moment. That's what we're going to look at. So we knew that this was 4, this was 6, this was 8, and then we said that each of them is going up in 2 each time. Okay, now we had obviously found 2 other terms, and that's fine. So I think we found 29, and we know that goes up in 10, and we found 41, that goes up in 12. Okay, we don't need to go up that far. It's just a little bit more information if you would like. So the first step here, step 1, find A. Now A in this sense, before we said A was the first difference. A is going to be the second difference divided by 2. Okay, and it will always be divided by 2, always. So what we are going to have is 2, so A is equal to 2 divided by 2, which gives me 1. Okay, so it's always going to be divided by 2, always. So now we found that A is equal to 1. Okay. Again, just giving you a little bit of time to get that down. And then we're going to look at finding the first. We're going to find out the first term. Or write an equation for one equation. Okay. So just while you're taking that down, you'll remember from linear patterns. Let me just put this in presenter so I can write this up here. You'll remember from linear patterns, when we were looking at linear patterns, we said that this was T1, this was T2, this was T3, and this here is T4, and then we have T5 and T6. Now, one thing about this is we know that, so what we knew from linear patterns before was that if I found a formula to represent a sequence, then if I put in the number 1 instead of n, I got the first term. If I put in the number 4 instead of n, I get the fourth term. So we're going to use the exact same concept, but we're just using a little bit of a different formula for this. So I'm just going to zoom that out a little bit to go down onto the second part. Okay, so on this, step 2, write the equation for the first term and fill in the variables that we know. Now, I just want to say to you, sorry guys, I want to take it off that there. I just want to say to you on this, if you can't see, let me know if you can't see the steps, okay? Because I am kind of making it a little bit smaller, just so that I can write. So if you can't see step 2, just let me know. I'm just going to zoom up a little bit there. Don't mind step 3 and step 4, we're not going to do them today. Okay, so step 2, write the equation for the first term and fill in the variables that we know. So we know that our first term, T1, is equal to the number 1, and we can see that here. So what I'm going to do is, I am going to write T1, and what I'm going to say is T1 is equal to, so we know that I'm going to fill in anything I have here. So what do I know about this equation here? Do we have any information about this? We have one information, or one piece of information, and that's that A is equal to the number 1. So I'm going to pop that in. So I have 1, and then I have n squared plus bn plus c. And when I put in 1 for any of those values, I should get the number 1 itself. Okay? So the first thing I did there was I just subbed in the number 1. Okay, so for n is equal to 1, what I'm going to do then, I am going to say 1 by 1 squared plus b by 1 plus c is equal to 1. Again, if there's anyone who's like, oh my god, I don't know what she's doing here, you need to ask me, where am I losing you? B is just a constant, it's a number, okay? Just going to move that up a little bit. I'll just zoom in on it so you guys can see it. So what I want to do now is I just want to simplify that. Okay? The last form. Okay, so Holly, what I did here is, this is my formula I start off with. First of all, I subbed in A, which is 1. Okay? And then, no, I switched it because I'm using the first term. And T1, the first term, is equal to 1. So instead of, we normally have n here. Instead of n, I'm swapping in 1. You'll see in a second up here that instead of n, I'll swap in 2. So why I put in the 1s, Laura, is because we're looking at the first term, T1. Okay? Okay, so simplifying that, 1 by 1 gives me 1, squared is just 1, plus b by 1 is just b, plus c equals to 1. Now you'll remember, if I want to just tidy this up further, so what I'm going to do, and I'm just going to do the quick way, is that I'm going to take this 1 and bring it over the far side. And when I do that, it becomes minus 1. So I get b plus c equals minus 1. And I'm just going to box that because I'm going to use that later on. So I know we're kind of running over time now a little bit. I'm just going to do step 2. And then or step 3, and then I'll leave it at that just so you can see. Okay. Now I have this on record, so you can go back over it this afternoon, if you're not sure. So I'm just gonna drag up here. So step 3, write the equation for the second term. So if we look over here, our second term is 5. So we have T2 equals 5. Okay. Did I say -1? Thank you, Howie. I said 0 in my head. Let me just wipe that. That should be 0. 0, because 1 minus 1 is obviously 0. Thank you very much. Okay. So just bringing it over here, writing the equation for the second term. So you will see now, we're going to use this Tn formula again. So I'm just going to write it out. Tn is equal to an squared plus bn plus c. Now I know that T2 is going to be equal to 5. Okay, because we have it up here. T2 is equal to 5. So again, I'm going to just replace what I have. So 1, I have n squared, and again you could later on you can skip some of these steps, plus c is equal to 5. Okay, 1, I got the 1 from my a equals to 2 divided by 2, which is 1. And then what I'm going to do is I'm going to replace n. So replace n. So what I get is 1, and instead of n, I'm going to put 2 because we're looking at the second term. By 2 squared plus b by 2 plus c, and that's all equal to 5. Let's bring this guy down. The last step here is to simplify. Okay, so we're going to simplify. So I have 1 by 2 is 2. 2 squared is 4. Plus 2 by b gives me 2b. Plus c equals 5. Now again, to tidy up this, so you can use the balancing method or you can use the loop method. So I get 2b plus c equals, when I bring that 4 across, I get 5 minus 4, which gives me 1. And that's the first part of this question. Now, tomorrow I'm going to show you how to solve this simultaneously. I don't predict we'll have this nailed down this week. Could be next week, could be the week after. But it's really important that you try and follow the steps yourself. So there's so much of this that even if we're in the classroom, so much of this that I can go through with you. And I obviously will go through loads of questions on these. But you need to go over the steps yourselves.